Welcome back, Hononegah, Algebra 1, 9.1, Day 2. So we're going to expand on goals that we did previously on simplifying. So here we go. Adding square roots. Anytime you're adding square roots, you're adding it just like you would if it was a variable. So you must have the exact same radical. When you have the exact same radical, you're going to keep the radical the same and add the coefficients just like you do when you deal with variables. 3x plus 7x is 10x. Notice change the x and you just add the coefficients. So 5 square roots of 7 plus 2 square roots of 7 would be 7 square roots of 7. Notice that I did not change the radical, merely added the coefficients. So in order to add and subtract, and that is the key, in order to add and subtract radicals, they must be the exact same radical. So 11 minus 12 is negative 1 square roots of 3. So this next one, what they're trying to get you to see is there's some that you can add together. So like 4 square roots of 5 and 1 square root of 5 can be added together. But 1 square root of 3 is different and therefore cannot be added with the other radicals. Now, D, then you're going to say, well, there's nothing I can do. Here's where in 9.1 Day 1 comes into play. I can actually break down 24. It has a pair, so 2 square roots of 6. And now that they do have the exact same radical, 2 square roots of 6 and 3 square roots of 6 makes 5 square roots of 6.
So right now I'm looking at E and saying I can't add that together, but I'm going to see if I can break any of these down. So I have a pair of 5s. 3 times 15, 3 times 5, there's a pair of 3s. And now I can add them together. So E
is definitely on your
quiz and on your test. So 4 square roots of 5 plus 5 square roots of 5 plus 3 square roots of 5 makes 12 square roots of 5. Notice that I didn't
change the radical, merely added the coefficient. 63 can be broken down. 3 times 21, 3 times 7, there's a pair of 3s. Now, here is where a lot of people will get this wrong. There's already a 6 on the outside, so that's negative 18 square roots of 7. So 4 square roots of 7 minus 18 square roots of 7 is negative 14 square roots of 7. Hit pause and try the next one by yourself. All right, welcome back. 2 times 16, 2 times 8, 2 times 4, which is 2 times 2. It's a pair of 2s and a pair of 2s, which makes 4. Square root of 2 plus 1 square root of 2 makes 5 square root of 2. So that is adding and subtracting radicals. Now, today we are only going to talk about multiplying
radicals. Tomorrow we'll talk more.
We'll talk
more about dividing. So here is the situation if you are multiplying. You can multiply any
two radicals together as long as they are the same degree, which they will be for this particular class. So you can multiply any square root times any square root. So here's what you should do. Times the square root of 20
is the square root of 100. Then simplify the square root of 100. So the square root of 100 is just 10. If you did a factor tree, let's say you didn't realize that it was already a perfect square, you would notice there's a pair of 5s and a pair of 2s and no singles.
You always multiply the outside numbers
together and the inside
numbers together. So this would be 2 times 1. Square root of 12 times square root of 3 would be the square root of 36. Square root of 36 is already a perfect square. So then 2 times 6 would be 12. Square root of 3 times
square root of 75 makes the square root of 220.
Now the square root of 225 is actually
Perfect, it's 15.
Many of you
May not have known that, so divide by 5. Divide by 5. It's a pair of 3s, pair of 5. So they get to go out, which is how I got 15. No singles left over. So multiplying the radicand
inside the radical. So 18x
x times
5x would make 90
squared.
This goes back to day 1. 3 times 30, 3 times 10.
2 and 5. Now,
Pair of 3s, they go out. There's a five. So they both of
them are single, so they both
stay back inside the radical. X squared has one pair with nothing left over. Now this is just upgrading our multiplying. So everything that we've done so far with multiplying has basically been a binomial times a binomial.
well, now we're going to upgrade it to a
It's a
binomial, meaning I'm going to distribute square root of 36 minus 1 square root of 6. Square root of 36 is a pair. And so the answer to this question, you can't add
together
if they don't have the same radical. So the second one has a radical, but the first one does not. So multiplying 4 square roots of 5. A common mistake here is to make that the square root of 20. The square root of 4 times the square root of 5 would be the square root of 20. So if the 4 doesn't have a radical, that is an outside number. So 4 square roots of 5 plus the square root of 25. I break down the square root of 25 because it has a pair, and then I cannot add them together. The first one has a square root, and the second one does not. So I can only add and subtract things that have the exact same square root. Square root of 3 times 5
2 makes 5 square roots of 6. Now,
that I multiplied.
it's inside the radical with what was inside the radical. So the
Next one would be the square root of 9. Now, the square root of 9 can be broken down into just 3, and that's it. I
them together because they don't have the same radical. Adding and subtracting requires the same
radical.